Hi, this is built from scratch. Today I want to share Rust smart pointers. Smart pointers first is box and RC and RefCell. The first is box, and for use box, there are some cases that box can help. And when you have a type whose size cannot be known at the compile time, and you want to use the value of that type in a context requires exact size. And when you have a large amount of data and want to transfer ownership, but ensure data won't be copied, and when you want to own a value and care only that type, it's a type that implements a particular trait rather than a specific type. And it can help in scenarios where you need to explicitly manage ownership, or you want to move ownership of data to another part of your program without unnecessary copy. Let's see some code examples. First we define create a variable that stores a box data, and this data is stored allocated on a heap. And here we store box integer and box str. And another very useful case is we can use box in a when define some recursive data types. For example, a list contains the current value and a pointer to next value. But if we directly use list as a next pointer, we will have error. Recursive without indirections. Insert some indirections. Here, the compiler suggests use box. So yeah, and in compile time, Rust needs to know how much space a type used. However, in the recursive data type, the type's memory usage continues infinitely. So Rust can't know how much space it used. But because box has a known size, we can enable recursive type by insert a box in the type definition. Yeah, and here we create a list with box new connected 1, 2. Let's run this example. Yeah, you can see we have a list 1, 2. Let's check another example that first we have a trait, and it has a draw method. And we also have some specific type button input. This is a UI widget that needed to implement the UI trait. And after button and input implement the draw method, we have a render function that receive a vector of UI trait, but we don't know the exact type at runtime beforehand, and we just declare the widget list should be a UI trait, should implement the UI trait, and then we can call each draw method on every widgets. So in the main function, we create a list of widgets, use box new button, box new input, and call render to pass the widgets that implement the UI trait. This is also a very useful example of box. And the third use case for box is that if we have a large object and we don't want to copy that object when call some function, so we create the object on the heap and pass the boxed object to the function, so it don't copy the data into the function. And you can see the box size only 8 bytes. And the second smart point is the RC reference count. It is used when you have multiple owners for a single value. And Rust enable multiple ownership by using RC, and RC keeps track of the reference to the value. If there are 0 reference to the value, then the value can be cleaned up. Okay, let's see one example. Okay, and for the example, we also create a list, and it has current value and a pointer to another list. And in this case, we create a common list hub with RC new, and we have 2 other lists to point to this list 1. So we use RC clone to let the list 2 and list 3 point to list 1. And initially, when we create a value with RC new, the reference count increase 1. So after RC new the list, the count is 1. And each clone will increase 1 reference count. So the final list count, reference count for list 1 is 3. you can see after the final reference count is 3, and the place 1 and place 2 all connected hard. And the third smart point is RefCell. For RefCell, it's used to enable interior mutability pattern. In Rust, it allows you to mutate data when there are immutable reference to the data. And normally this Rust is not allowed to do this, to do multiple disallowed by Berlin rules. So we use RefCell to use the interior mutability pattern, and the Berlin rules are followed at runtime. And it is very useful when you sure your code follows the Berlin rules at runtime. Okay, let's see an example. So we also want to create a list to demonstrate, and we define our list to be const value t and wrapped with box and RefCell list. And for box, because we need to let compare known the next list size, pointer size. For RefCell, we need the interior mutability to modify the next point when we add new values to this list. So initially we return a new value for the list, and when we add a value to current list, we first check the current value. If it's a new value, then we directly change the current value to be a list const value, and box new RefCell with list new value to be the next point for current value. If the current value is const, then we call borrow mute. Borrow mute will enable the interior mutability for the next list, and make it can recursively call our current add function to add the value to the list. And when next point call add, it also follows these rules. Yeah, and we can add values. Let's see how the list goes. First, after initial, the list will be new, and then it will be const 1 and list new. And add 2, it will be const new 3 will be const 3 so 100. Okay, and we can print the values in the list by continue consume the next pointer. And if current value is not new, then we print the value and borrow the next pointer to make the current list continuous until it meets list new. And you can see we print values as the insert order, followed by insert order 1, 2, 3, or 100. Yeah, and okay, for summary, and box allows immutable and mutable borrows checked at compile time, and it allows we store large data in the heap, and it also allows us to receive a list, a vector, a list of type that implement a trait. And for RC smart point, it enables multiple owners of same data. And box and RefCell have single owners. And RC only allows immutable borrows checked at compile time. RefCell allows immutable and mutable borrows checked at runtime. And by the way, for RefCell, we cannot have multiple borrow mute to be called at the same time. For example, if C we borrow mute twice for V, and it will actually can panic. We call add. Yeah, and we cannot, as you can see, we cannot borrow and borrow mute at the same time. Then it will be panic. And for RefCell allows mutable borrows. at runtime, so we can mutate the value inside the RefCell. T, even the RefCell is immutable. Alright, that's today's video. Thanks for watching.